It was not rotating horizontally. It will cancel. If you cancel it, it will now create another line. That's the challenge that day. I don't know why. Click OK now, the life will end. Put it straight first, put it horizontal, let's see that can still work. And put it vertical, let's try that, I can manage it. You understand? Put it good like this, I think we can still do. Still covers the board. Because that was the problem that day. Okay, let's go like this. Have you? So that was that day, we still kept on. Was blue. All right. Hope you can.
Yes.
It's okay now. All right. Good evening, everyone. Welcome to this live stream where we'll be having a good time revising for our exams. For those of us that are preparing for exams, this is an opportunity to really prepare and wait. Some persons are waiting, the strike has kept you on hold, but then your studies should not be kept on hold. So you are welcome once again to this live stream. So if you are present, please quickly indicate. Just say, I'm present. How many persons are there now?
5.
Just indicate, send a comment, drop a comment. Tell us how clear it is from your end. How bright is it from your end so you can see very well. So tell us, drop a comment. Stable. All right, tell us how bright it is. Let's wait to get 10 persons and we can move on. Because we want to quickly, I'm going to touch 2 major aspects, then we'll schedule another day to touch the last. Remember, we're still dealing with optics. So this time we're going to cover lenses, talk about optical instruments. We're going to then talk about waves. So hopefully I want to cover waves today so that it would remain thermal physics, another important part. So hit the like button. If you're already present, just hit the like button. Hit the like button. How many likes do we have now?
7.
7 and 7 persons.
6.
Okay. Share the video, please. Before I move on, just share it to your class group. Tell them prime concept is live. Remember, early preparation aids good success. So don't procrastinate your preparation. Share the video link. Share it. You can share it back to Prime Concept WhatsApp group. Share it to your class group. Tell them that we have started. We have up to 10 now.
No.
Still 8. Okay. Please share. Once you are coming, you hit the like button. Drop your first comment that I'm present. Register your presence. Who are those present? Let me see.
We have Ikechuku.
Ikechuku, welcome to the live session. Chikechisom, you're welcome. Juliet, welcome. Juliet, do share with your class group. Invite other girls. Chidima, do share with your class group. You're welcome. Nkem thank you. Precious, thank you. Welcome. All right, so please hit the like button and then share with your friends. Tell them we have started. So basically, we're going to look at lens. I'll try not to be too fast in as much as it is revision. Some persons would have forgotten this concept, so, but I'll try to still go gradually because we're still going to have another live session. Hopefully tomorrow being Saturday or Sunday, we're going to make you send a notification, right? Now quickly want to look at lenses. Now you notice we've studied mirrors. For those that missed, you can check my YouTube channel, you'll see that. So we want to look at lenses. There are two types of lenses we consider. But before I move on, so that while we are waiting for others to join, let me do a quick revision. We mentioned that there are three types of curved mirrors. When we studied mirrors, we said there are three types of curved mirrors. I want you to drop the answer to these curved mirrors. Drop the three curved mirrors we have. I mentioned that there are three types of curved mirrors. If you know the answer, type the three of them, the three types of curved mirrors we have while you are waiting. Any answer?
Not sir. I said they're not seeing the barrier.
Okay, you can't see, it's dark. Then it can't be this. Okay, let's work on it. Give us 1 minute. You can't work on this. This is what I strongly target. So you just put on light. I think it's dark, right?
Mm-hmm.
Open from your
Or maybe you should just go back. Like, find a way, go backward.
No, it's not still solid. I'm not writing yet. Can you see me now? Remember, the weather is really affecting the rain.
It's clear now.
Huh?
It's clear now.
Okay, it's clear. Alright. How many persons are there?
We still have 6.
The rain is really disturbing. So we have to prepare for our exams. Has anybody typed the answers?
Yeah.
I asked the three types of curved mirrors, right? So let's see.
Chicken, say,
Chicken.
binocular,
My God.
meniscus.
Meniscus. Okay, any other answer?
No.
Alright. The three types of curved mirrors I mentioned. Concave mirror. Let me quickly write them. Concave mirror. Talked about the convex mirror. Then we talked about the parabolic. These are the three types of curved mirrors we mentioned. The concave, the convex, and the parabolic. We mentioned a special thing when we studied the mirror. We said that the concave and the convex mirror would always introduce what we call spherical aberration. That is to say, the light rays would not converge at the focus where they should be converged. To correct spherical aberration in these two mirrors, we said that you use what? A parabolic mirror to correct spherical aberrations in mirror. So these are the three types of curved mirrors we mentioned in our last class, just for the sake of a quick review. So we also mentioned, before we now move to what we have for today, when we talked about refraction at plane surfaces, we mentioned the concept of total internal reflection. We said total internal reflection would occur under two conditions. Conditions for total internal reflection. So we said there are two conditions. Can you give me those two conditions quickly? Then I will move on to what we have for today. How many persons are there now? 8 persons. So give me the two conditions for total internal reflection. Very quickly. I'm waiting. Type your answer. Don't be scared of failing. Remember, it's a revision class. It's better you fail it now and pass in exam than to fail now and also fail in exam. So try, make an attempt. Tell me the answer. The conditions for total internal reflection. Number one, I'm waiting. Any answer yet?
No.
I'm waiting. Let me see from your phone. I'm waiting. Any answer yet?
No.
I hope it's not network. Let me be sure I'm using 4G today. You see, it's not 4G.
It's not 4G.
Maybe that's.
Okay. Michael Blessing said, light must move from optical dense medium to less dense medium.
Light must move from an optically dense medium or denser medium to less dense. Very correct.
Chukwuemeka said, refracted angle must be greater than.
Okay, good attempt, but it is not part of it.
God I live for said, the angle of incident exceeds angle of critical.
Thank you. So the angle of incidence should be greater than the critical angle. So these are the two conditions. One, you must move from denser to less dense. Number two, incidence should be greater than critical angle. These are the two conditions for total internal reflection to occur. Now we want to move to our study for today. Very quickly, we want to study lenses. Now there are two types of lenses, two main types of lenses that we have. Number one is our convex lens. Number one type of lens we have is our what? Convex lens. Now let me quickly let you know that the convex lens is also divided into three types. We also have three types of convex lens. One of them is called biconvex. If you don't want to call it biconvex, you can call it double convex. That is number one type of convex lens, right? And what is our biconvex? This biconvex is actually what we refer to as the convex lens. So you should take note. Whenever we say convex lens, we are referring to biconvex. And this is the shape of the biconvex lens, like this. So please take note of these things. The second type you have is what? Is planoconvex. That is to say, a convex lens that has a plane surface like this is planoconvex lens. Number three type of convex lens you have is what? Concavo-convex lens. Concave convex lens, like this. Concave convex lens. So these are the three types of convex lens you have. Now remember, anytime we say biconvex or anytime we say convex lens, this is the one we are referring to. Biconvex is what we are referring to. So take note of that. So we have the convex lens. So specifically, I will be talking about convex, which is the biconvex. So let me rub the board very quickly. So what is our convex lens? What is our convex lens? Our convex lens is a lens that is thick at the center and thin at the edges. That is your convex lens, like this. A lens that is thick at the center, you can see the thickness at the center is greater than the thickness at the edges. So that is your convex lens, right? Now your convex lens can also be called a converging lens. It can also be called what? Converging lens. That is to say, it converges light that enters through it. So if you have your convex lens like this is your convex lens, and you incident light like this on it, it would converge at a point. It would converge at a point. So that is your convex lens. Now I want to point out, before I move on, there is a major difference between a mirror and a lens. And what is the major difference between a mirror and a lens? A mirror is a reflecting surface. A mirror is a reflecting surface. A lens is a refracting surface. Take note of this point I've mentioned. Mirror is reflecting. Is a reflecting surface. While your lens, the two types of lens are what? Is refracting. Refracting surface. So your mirror is a reflecting material, while your lens is a refracting material. So you take note of that, right? Now you should also know that for your mirror, one side of your mirror is coated. But for lens, a lens is a transparent material. Take note of this. Exam can ask you which of the following is true for a lens. A lens is a transparent material. A lens is a translucent material. A lens is a absorbing material. So you will see different options, but you should take note that the lens is transparent. That is to say, if you flash light on a lens, you will see the light on the other side. It's transparent. If I hold a lens, I can see through a lens. And that is why you can use lenses as your spectacles. That is why, because it is transparent. You can see through it. So quickly, I'm talking about the types of lenses, right? We say we have our convex lens, which can also be called converging lens. Number 2, we have our concave lens, which can also be called diverging lens. You can also call it diverging. When you say diverging is the spreading away. So you have your concave lens, which can be called diverging lens. Now remember, we also have 3 types of concave lens, and this is important. When we get to another part of this course, you would learn why this is very important to us. So we have 3 types of our concave. One is our biconcave, which you can also call double concave lens, right? Double or biconcave. And this is the diagram. This is our biconcave. Now, anytime you hear us say concave lens, we are referring to the biconcave lens. So it means that the 2 sides are concave surfaces. Number 2, you have the plano-concave. You have plano-concave. Then you also have the diverging meniscus. You call it diverging meniscus, or you can call it convexo-concave lens. Convexo-concave lens. So take note of these 3 things: diverging meniscus or convexo-concave lens. Now I can rub this. Now all the terms, when we studied mirror, we talked about terms that are used in mirror, right? Now most of these terms are also applicable to lens. So let me quickly help you. If this is our convex lens, I'll be working with convex more. This is our convex lens or converging lens. If I locate a center of that lens, for mirrors, the center of a mirror is called pole. But for lens, the center of a lens is not called pole. The center of a lens is called optical center. Optical center. So this is the optical center of my lens. Now, I draw a straight line through the optical center. This straight line is also known as my principal axis, principal axis. Now, one special thing about lenses is that lens has two focal points. So lens has a focal point in this side, which you can call F. It also has a focal point at this side, which you can call F. Sometimes some books call this F1 and call this F2, or they can call this F2 and call this F1. But one thing you should know is that the distance from the optical center to this point is the same as the distance from here to this point. So that's why we can just call them F. Some other books call them F. So just take note of it, that you have two focal points, one on this side, the right hand side, one on the left hand side. Then the same way you have for mirror, you have center of curvature for mirror, but for lens, rather than center of curvature, you say 2F. That is to say 2 times the focal point. Same way, at this point, we have 2F. So this is how we describe for a mirror and for a lens. Please take note of that. Both for convex and concave is like that. These are concave, like this. We have something like this. This is F. This is F. This is 2F. And then this is 2F. The same way we have. So take note that we have two focal points. So I believe this is clear to you. Now, another thing I want to mention to you is that anytime, this is where you always place object. At the left hand side is where you would always place object. Now, anytime your image is formed on the opposite side as your object, image is always real. Take note of that. So it means if my image is formed on this side, it means image is real. For lenses, this is actually opposite for mirror. So if your image is formed on the opposite side of your object, image is real. If your image is formed on the same side as your object, then image is virtual. So it's a very important point you take note of. Now let's quickly move on. So these are the terms you want to know, the extra terms, which is optical center and then 2F rather than center of curvature. So take note of this. So very quickly, we are going to look at rules for image formation. Rules for image formation. How many people do we have now?
12, 18 likes.
Okay, thank you. So we want to look at rules for image formation. The same way we considered rules for image formation in mirrors. I'll be bringing these things because we are doing a revision session. So I want you to give me one rule. Each of you give me one rule for mirror, because I want to talk about that for lenses. But let's recap on mirror. They are similar. So if you understand a rule for mirror, quickly drop for me the rule you can remember. Remember, anything you remember now, you won't forget for your exam. So once I ask you a question, struggle to answer it, because that is what this class is all about, revision. Normally it should be an interactive class. I'll just be throwing questions and you'll be writing the answers. So, but I would explain. So any answer?
Not yet.
So I'm waiting. Give me, not for lenses, I will teach you the rules for lenses, but we studied mirrors already. So give me one rule, each of you, for mirror. One of the rules you can remember for image formation in mirrors. I'm waiting. I'll give you 3 seconds and I'll move on. Any answer yet?
No.
All right. So I'll move on. Now we are looking at rules for image formation in lenses. This rule is applicable to both convex lens and concave lens. So number 1 is that rays parallel to the principal axis refracts, not reflect this time around, refracts through the focal point on the other side. So this is a very important rule. Remember I said I won't rush too much so that we can help you. If we still have need, we'll fix more live sessions. Since there is strike, we still have more time to cover. So I'll be going gradually. Rays parallel to the principal axis refracts through the focal point on the other side. That is one rule for lenses. This is what it means. Let me show you with the diagram. This is what it means. If this is my lens, say my convex lens, remember I have my focus here, I have another focus here, I have my 2F, I have my 2F. Now what this rule 1 is saying is that if I have a parallel ray like this ray is parallel to my principal axis. When it hits my lens, it will refract, bend through the focus on the other side. This is what rule 1 is saying. I hope you're following me. So this is what rule 1 is saying. So quickly screenshot it. Let me go to rule 2. You are ready to move. Say move on. I'm waiting. Please do well to interact with me. Type when you should type. Say move on once you are ready. So did anybody later type the answer for mirror?
Yeah.
Okay.
Someone said for concave mirror, when object is beyond C, it's real.
Okay, but that is not what we are asking. We're asking for rules like this that guides us. So can I move on now? Any response? Move on, right? So I can rub this. This is rule 1. Rule 2. Rule 2. Rays through the optical center. Through the optical center goes unrefracted, or you can say undeviated. So that is rule 2. When a ray goes through your optical center, you will visualize what that rule is saying. This is F, this is F, this is 2F, and then this is 2F. And the rule is saying, remember, this is our optical center. The rule is saying when ray goes through the optical center like this, it does not bend. It just continues straight like this. That is what this rule is saying. Any ray passing through the optical center would follow that direction, unrefracted, undeviated. So this is it. I want to rub and write rule 3. Rule 3. So screenshot. If you want me to move, always type. Just say move on. I would move. You have to interact with me so that I won't be running faster than you. So, all right. Now, the last. For lenses, we have only 3 rules. For mirrors, we have 4 rules. For lenses, we have only 3 rules. And what is the third rule for lens? Rays through the focal point, refracts parallel to the principal axis. So whenever you have a ray that goes through the focal point, when it refracts, it will become parallel to the principal axis. And what do we mean by this? This is what I mean. This is what I mean. So this is F. This is F. This is 2F. And then this is 2F. Now, if you have a ray that enters through your focal point like this, now you can see it's passing through the focal point. When it hits our mirror, it will now come out parallel to the principal axis. So this is what this rule is saying, right? Right? It's okay.
Yeah, come on, 6. It's just D.
What's that? All right. I hope you got this now. So I want to rub and move on. So these are the rules. For lenses, we are interested in 3 rules. For mirrors, we have 4 rules we consider. For lenses, 3 rules. So these are the 3 rules that we are interested in, right? A quick recap. First one, rays parallel to the principal axis would refract through the focal point on the other side. Second one, ray through the optical center goes through unrefracted or undeviated. Third one, ray going through the focal point refracts parallel to the principal axis, like you can see. So very quickly, we want to look at image formation. I will draw one. Among all the ones I would explain, I may draw 1 or 2 and move on. Remember, We want to take it gradually, so that you would really understand it to a great extent. I want to look at image formation. Image formation on a convex lens. Image formation on a convex lens. So we want to consider for convex lens image formation, right? Number one, very important, when objects, we're going to tell all these things, then we're going to draw any one of them. Number one, when object is at infinity, when object is at infinity, image is, I'm waiting for your answer. When object is at infinity, tell me, where will the image be formed? And then we're going to list the properties together like we did for mirror. I'm waiting for your answer. Any answer?
Not here.
My God, we have to be fast. When object is at infinity, image is at
F.
F. Thank you. Image is at F, the focal point. Take note of it. When object is at infinity, your image will be formed at the focal point. Very important, both for mirror, both for lenses. Anytime your object is at infinity, whether mirror or lens, your image will be at the focal point. Never you forget it. And when your object is at focal point, image will be at infinity. These two things are interchangeable by the principle of reversibility of light. It makes it true. Now, what are the properties? Number one, any property?
Not here.
Number one property of this is that the image is real. Image is real. Number two, image is inverted. And then number three, it is what? Diminished. It is diminished. So these are the properties that you should know for this. Please take note of this. Image is real, image is inverted, and image is diminished. I've told you, whenever you have a real image, you expect that it should be what? Inverted. If you have virtual, it should be what? Erect. You can never have real and erect. It is impossible. So these are the properties. So I want to go to number two condition. Number two condition. Number two, when object is behind 2f. When object is behind 2f, image is, who has the answer? Image is between 2f and f. Image is between what? 2f and f. I will draw it so that you understand, after which I won't have to draw again. Image is between 2f and f. Now let's quickly draw this so that you will see. So this is our lens. When I draw, you will now give me the properties. So this is f. This is f. Remember, I'm not drawing to scale, so I will do some adjustments so that I can get my results. This is f. This is 2f. Now, when your object is behind 2f, this is our object behind 2f, which is what we are considering. When object is behind 2f, where would the image be? So let's draw. First, I want to use one of the rules, the first rule, which says if I have a parallel ray like this, when it hits my lens, it would refract through the focal point like this. I want to use another rule, which say when it goes to the center, it will go through undeviated, so like this. So you can see this. Now, where the two rays intersect is where your image will be formed. Can you see their point of intersection? So it means that my image will be formed at this point. So, and you can see it is between f and 2f. So it is between f and 2f. In between, that is what I've said. Image is between 2f and f, or you can say it's between f and 2f is correct, right? So I believe this is really clear to you. Now, what are the properties of this image? One of the things you can see is that image is what?
Inverted.
It is inverted. It is inverted. You can see it facing down. If it is formed up here, it means it will be erect. So it is down here, it means it is inverted. If it is inverted, it will be what?
Real.
Real. Thank you. It will be real. Number 3 property.
Image is magnified.
Image is diminished, actually. Diminished.
Charles didn't get it.
Is diminished. Who got it?
Charles got image.
Charles.
Image is real, inverted.
Image is real, inverted, and
diminished.
diminished. Charles got the 3 of them.
Yes.
Thank you. So thank you. Let's move to the 3rd one. I believe I can rub this. Let's move to the 3rd one. Please take note of this. So remember, you are not just here to spectate. We are revising for exam. Don't joke with your exam. So all these things I'm giving you, if I'm too fast, tell me to reduce my speed so that you can write. So do well to write. It's very important. So if I'm too fast, just drop in the comments, say you are too fast, or continue like this. Tell me so that I will know what to do. Because you have to get these things. Your exam has to be A or nothing. Now, we want to look at the 3rd case, number 3. When object is at 2f. Remember, number 1, we said object is at infinity. Number 2, we said object is behind 2f. Our object keeps moving gradually forward. And number 3 now is when object is at 2f. Where will our image? Image is, I'm waiting. Who has the answer?
2F.
2f. You are correct. Who gave that answer? Chukwuemeka John Paul. Thank you. Congratulations. So image is at 2f. This is a very important and special case, right? Say we want to draw it. It's still the same storyline. Say we want to draw it. This is what we would have. So this is f. This is 2f. This is f. And then this is 2f. Now our object is at f, like this. So if I follow my rules, I have this. This is a parallel ray. When it hits my lens, it goes through, okay, it goes through the focal point. It goes through the focal point like this, even though my hand is not very straight. Now say I follow another rule. I go, okay, let's go through this. Let's use rule 3. You move through this like this. When it hits your mirror or your lens, it will go like this. My hand is not very straight. So, but this is the point of intersection for me, because my hand is not straight. So this is what I have. So the image is formed at 2f. At 2f. Now, what are the properties of the image formed? Number 1, image is inverted. Number 2, image is real, right? Yes. Number 3, it is what?
Same size as the object.
Same size as object. Same size as object, right? What it means is that your magnification m is equal to what? 1. Magnification is 1. So this is a very important case. They can ask you in exam, where should an object be placed in front of a convex lens so that the magnification is unity? What would you say? Object should be placed at 2f. When you place object at 2f, the image will be formed at 2f, and therefore magnification is 1, right? So object image is same size as object. Also, you should know that the height of image is the same as the height of object. The height of image is the same as the height of object. Quickly, number 4. How many persons do we have now?
17.
22
likes.
Okay. Where are the other people? Did they go off? Oh, okay, I think they were liked. Some people liked it before it started.
Network too.
So now number 4, we want to look at number 4. So keep sharing the video, share the link, tell others to join. We need to have up to 50 people online. Now, the next one, when object is between 2f and f. When object is between 2f and f, image is, anybody? Any answer?
That's it.
I'm waiting. Where would the image be when object is between 2f and f?
Beyond 2f.
Beyond 2f. Beyond 2f. Thank you. So image is beyond 2f. Thank you. That is correct. So as your object is coming close to your lens, your image is moving far from your lens. So that's why when your object came between 2f and f, image moved beyond. Let me still draw it. So this is what we have. This is f. This is f. This is 2f. This is 2f. Now this is where our object is, between 2f and f. Now let's see, even though I didn't create enough space there. So, but if you have rule 1 like this, it will go through this. If you follow rule 2, say you are passing through this point. Okay, let me follow here. This would give me, you can see, so it's intersecting somewhere around here. You can see it's behind 2f, or you can say beyond, which is a better term. Beyond 2f, you can see it. Now, what are the properties of this image? Number 1 you would always see is that it is what? Inverted. Number 2 is that it is real. Even a market woman knows this. It is inverted, it is real. Number 3,
Magnified.
it is magnified. This is the first case of magnification. It is magnified, right? So these are the properties you should know. This is the first case of magnification you are getting for a lens. It is inverted, it is real, it is what? Magnified. Let's quickly look at number 5, because we have 6 of them. Number 5, I hope I can rub this, right? I believe I can rub this. I believe, but let me give you 1 second. So number 5 we want to consider. Number 5 is when object is at f. When object is at f. When object is at f, what will this case be? What will this case be? I want you to give me the properties in this case. Type them quickly. I don't want to draw this. Maybe I may still draw, but I want you to give me the properties in this case quickly. I'm giving you some seconds. Let me talk to Jeff.
Okay, yes.
Any answer yet?
Yeah, the image is formed at infinity.
Image is at infinity. Perfect. So properties, image is at infinity. Very important. Image is at infinity. Remember the first case we considered, the object was at infinity, image was at f. In this case now, object is at f, image is going to infinity. So very important. What are the properties? Number 1,
it is real.
Image is real. It is real. Number 2,
Image is inverted.
Inverted. Number 3,
image is magnified.
It is magnified. So this is what you have. If I want to draw it, this is what I would have. This is f. This is 2f. This is f. This is 2f. So when our object is at f at this point, if I follow the rules, I have this, then it would refract through this. Then next is that, say I follow this one, it will go this way. Now you see that these two rays are parallel, so they will not meet. It simply means that they are going to infinity. That's why we say that the image is at infinity, right? So I believe this is really clear. Let's look at the last one. So I'm giving you time to screenshot, or you write it so that I can move. Can I move now? I think I can move on now. Now, number 6. Number 6, when object is between F and optical center. So we either say when object is between F and optical center, or we say when object is between F and the lens. So when object is between F and the lens, where will the image be formed? Where will image be formed? Who has the answer? Anybody?
That's it.
Where will the image be formed? A quick one. Image will be formed. Image is on same side as object. Remember what I told you earlier? Image is on the same side as object. Now quickly, this is what the diagram would look like so that we can now form the properties. So this is F, this is 2F, this is F, this is 2F, right? Now, this is where our object is between F and our lens. So if I follow my properties, my rules, I have this. When it hits my lens, it goes through this point. The next one is, say I consider my optical center, it goes like this. Now you notice that these two rays are not parallel. They are just spreading away from each other. So it means they would never meet anywhere in front. But if I take these two rays backward, like this, you would notice that they would intersect somewhere. Even though my hand is not very straight, but you would notice that both of them will meet somewhere and form an image. So this is now the image. This is now the image, and this is our what? Object. So you would notice that the image is on the same side as your what? Object. Right? Now, what are the properties of this image? I believe you can see the properties. Number 1 is that it is virtual. The image is what? Virtual. Remember I told you when you have image on the same side as object for lenses, it means it is virtual. If it is opposite side as your object for lenses, it is real. So in this case, image is what? Virtual. Number 2, image is highly magnified. Highly magnified. And number 3, it is erect. Number 3, it is what? Erect, or you can say it is what? Upright. That is number 3. Now, one of the special things I want you to know is that it is under this condition that your convex lens is used as a simple microscope. It is under this condition that your convex lens can serve as a simple microscope. You don't want to call it a simple microscope, you call it a hand lens. You call it a magnifying glass. It is under this condition. And what is the condition? The condition that the object should be between F and the lens. You can see it. So this is a diagram for simple microscope. When I get to the topic simple microscope, I don't have to draw again. This is the diagram for a simple microscope. So simple microscope would always give you a virtual image. Never you forget. So this is it for simple microscope. If you get those days when you were in, say, secondary school, you played with lenses. Maybe when you get your convex lens and you place it under the sun and then put leather under it, you notice it will burn that leather. So that lens can actually serve as your simple microscope because it can magnify. Now, let me quickly rub this. We are done with image formation for convex lenses. We are done with image formation for convex lenses. Can I do a recap? I think it will be necessary to recap on these properties. Number 1, just follow me. We're going to do it together. Where you are, just be mentioning that with me so that I can see how good you can remember these things. Number 1, when object is at infinity, where will the image be formed? Image will be formed at what? At F. What are the properties of this image? The properties, the image will be what? Real. It will be what? Inverted, and it will be what? Diminished. This is number one. Number two, when object is behind 2F, where will the image be formed? When object is behind 2F, image is between F and 2F. Image is between F and what? 2F. What are the properties of this image? Number one, image is real. Image is inverted. Image is diminished. Number three, when object is at 2F, where will the image be formed? Image will be formed at 2F. What are the properties of the image? Image is real. Image is inverted. Image is same distance from the lens as the object. Image is same distance from the lens as the object. Image is same height as the object. So it means that image height and object height are the same. Therefore, magnification is what? 1. Next one, when object is between 2F and F, when object is between 2F and F, where will the image be formed? Image will be formed beyond 2F. Image will be formed beyond 2F. Now, what are the properties of this image? 1, it is real. 2, it is what? Inverted. 3, it is what? Magnified. This is your first case of magnification. Next one, when object is at F, where will image be formed? Image will be formed at infinity. At infinity. Take note of that. And the image is what? Real. It is inverted. It is magnified. Now, exam can ask you, where will an object be placed in front of a convex lens so that the image cannot be seen? Let me write it. Where will an object be placed in front of a convex lens so that the image cannot be seen? So tell me the answer. Check who has the answer.
At infinity.
Where? Somebody got it?
Yeah, at infinity.
At infinity. My God.
Okay.
Where will object be placed?
At F.
At F. Thank you. When you place your object at F, the image will be formed at infinity. It means that the image cannot be seen. Something that is at infinity cannot be seen. That is what it means. So take note of these exam tricks. Now, I want to look at image formation before we now get to calculations. I want to look at image formation. Image formation for concave lens. Image formation for concave lens. Very important. Remember, we have done convex lens. Concave lens is just one case. Just one case. Very simple. Now, irrespective of the position of your object, image is formed on the same side as object. Let me write it. Image is on same side as object. Image is on same side as object, irrespective of object position. That is to say, the image position does not depend on the position of the object. So wherever you place that object, image will be formed on the same side. This is it. This is it. This is it. This is F. This is 2F. This is F. This is 2F. We don't even have to need to label this anyway, this side. Now, say I have my object here. This is my object. We follow the rules. You have this You have this to go through these points, right? Yes. And then it will diverge, sorry, to go like this, appear as if it is actually coming from F. Because remember, your concave lens is actually a diverging lens. So when light enters it, it will always spread away. It does not come down. Because when it comes down, it means it's converging. So that's why when this hits here, it will spread out. It will now look as if it actually started from the focal point here to move out. Same way, if it goes through your optical center like this, you now have it like this, so that these two look as if they are diverging. That is why this is called your diverging lens. And then where do they intersect? You can see their point of intersection. So this is where your image will be formed. This is where your image will be formed. So this is our object. This is our image. So for our concave lens, image is formed on the same side as object, just like you can see. You can also notice that your image is highly diminished. Your image is highly what? Diminished. You can see the image is smaller than the object. So image is highly diminished. So take note of it. And then image is what? Virtual. The image is what? Virtual. Also, the image is erect. You can see it. It is erect. I gave you three properties. One is that image is diminished. Two is that image is erect. Three is that image is virtual. Take note of those three properties for your concave. And this is the only scenario we have for our concave lens. Remember, your concave lens can also be called diverging lens. That's why you can see this diverging. So I believe this is clear to you. Then we want to quickly look at the mathematical formulas in lens. Mathematical formulas in lens. Now, at this point, I want to pause and ask you, tell me whether I'm too fast or I should continue at the pace. Tell me, type very quickly so that I will know how to move, whether to reduce my pace further or to continue at this pace. I'm waiting for your response. Say continue like this or reduce, right? So that I will know. I'm waiting. Any answer?
No.
How many persons are there now?
15.
15. I want you to be 50. And I know you can make it happen. Share it. Share the link to your class groups. I want this live. I want us to have up to 50 persons, right? Remember, it's not easy. It's not an easy work to do a live video. It costs a lot of data, right? Then a lot of commitment and time on my side. So one of the ways you can show your support is by subscribing. If you are watching this video now and you have not subscribed, it's just very easy. Just hit the subscribe button, turn on the notification bell, like the video, then share with your friends, share it to your class group, reshare it to prime concept group. Something very important and serious, right? So what are they saying?
Continue like this.
Okay. All right. Now I want to look at formulas. Formulas in lens. Now, there are formulas that you need to know, like we said in Miro. One formula that is very important to us is what we call lens formula, which is 1 over F equals 1 over V minus 1 over U. Take note. For Miro, we used plus, but for lens, we are using what? Minus. Take note of the difference in these formulas. 1 over F equals 1 over V minus 1 over U. If you check my videos on this channel, you would see I showed how this formula came about. I derived it. So for now, it's a revision class. No point for derivation. Now, this is one formula you should know. Recall that F is focal length. F is focal length. V is image distance. U is object distance, right? Yes. Number 2 formula you should know is formula for magnification. M is V over U. Or you can still say number 3, M is HI over HO. So these are formulas you should know. And then there is one more that is not so important because we can do without it, but let me write, because exam can also tell you which of the following formulas can be used for lenses, right? Now, very quickly, the fourth formula. See what I will do to get the fourth formula. You can see this first formula. If I multiply every part of this formula by V, you will see what I will get. I'll multiply this by V. I'll have V over F. I'll multiply this one by V. I'll have V over V. I'll multiply this one by V. I'll have V over U. So that this is V over F equals V over V is 1 minus V over U is M. Actually, magnification is image distance over object distance. So if I bring this M to this side, this minus M becomes positive, equals 1. When this one crosses, it becomes minus V over F. So this is a formula you should know also for magnification. It will give us the same answer as V over U. So we can also use this formula for magnification. So this is our number 4 formula. So these are formulas I want to point out is the sign convention. So I'm giving you time to either copy this or screenshot, then I'll move on. All right, so we want to look at sign convention, which is what will help us to be able to apply the formulas. Sign convention for convex lens. Number 1, remember we did sign convention for mirrors. It means that if the concept of sign convention is not clear to you, you won't be able to solve problems. So it means you really need to understand the sign convention. So number 1, sign convention for U is always negative. U is always what? Negative. Number 2 convention, this is true. Now, any other convention you have learned, please don't mix it. Just ignore what you have known that maybe you are not very sure of, and just follow this, and you'll see that you will get every problem you solve following this convention. Number 2, F. F is positive. Remember, we're dealing with convex lens. Don't mix it. This is convention for convex lens. For convex lens, U is negative, F is positive. If you remember for mirrors, convex mirrors still follow this thing. Then convex lens follows the same thing. So don't mix it. Then number 3, V. Let me say, if image, let me put it this way. If image is real, comma, V is negative. If image is real, V is positive. If image is virtual, comma, V is negative. So this is what you should know. So the moment they tell you a real image, you know that V is what? Positive. Once they say a virtual image, you know that V is negative. So you don't need a soothsayer to tell you. They can still tell you an image is formed on the same side as the object. You should know that it is a virtual image. So take note of these conventions. These are applicable to our convex lens, right? Now, the next we want to consider is for our concave lens. Then we'll take some problems. We'll take some important problems. Now, I want to I've allowed you time to copy. So sign convention for a concave, lens. For concave lens, U is also negative, F is negative, then V is always negative. So this is just the simple convention for this. So copy that. Let's take a problem. Now, I believe you're done with this. So let's take this example. We'll take like a good number of problems. An object is placed 6 cm from a thin lens, a thin convex lens, a thin convex lens of focal length 10 cm, full stop. Determine the nature, position, and magnification of image. So, can I allow you to attempt? If you want to attempt, say wait, quickly type wait. If you want to attempt, or say continue. Let me know that I should allow you 15 seconds to attempt it. Remember, it is revision. So I'm sure you are with your pen and paper. So if you want me to allow you attempt, say wait, then I will know any question I give, I would wait for you to attempt. If you want me to just be solving, say solve.
Wait, sir.
Okay. I solve. 15 seconds. Any answer?
No. Okay.
All right. Who has the answer?
Charles
Charles.
said 3.33 cm.
Let me write it. 3.33 cm. This for what?
I think that is for the natural position.
The
Then-
position.
Yeah.
Okay, that is distance. V.
Then magnification 0.67.
0.67. Mm-hmm.
Ernest.
Ernest. Okay.
Only 4.
Huh?
4.
4 for V.
You
Uh-huh.
don't notify anyone. Just 4.
Okay, maybe it's his magnification. Any other answer?
Okay, for magnification.
Okay, that is M. Any other answer?
No.
I think I would solve now to save our time. Now, the question says an object is placed 6 cm from a thin convex lens. So we're dealing with a convex lens, and the object is placed 6 centimeters from the lens. So it means that U is actually 6 cm. Remember, for our lens, both convex and concave, object should be negative. So U is minus. Lens of focal length 10 cm. So our F is 10 cm. For our convex lens, focal length is positive, right? Now they say we should determine the nature, position, and magnification. Now, what does position mean? Position means image distance. Position of image means image distance. Nature means tell us whether it is real or virtual. That is what nature means. So position means image distance. So I'm going to rub the board so I can solve. Can they see this side?
Yeah.
Okay. So now I'm going to solve using my lens formula. 1 by F equals 1 by V minus 1 by U. So I have 1 by F, and my F is 10, equals 1 by V minus 1 by U. Remember, my U is minus 6. So you would quickly notice that this minus and this minus would become plus. So let me change it. Minus times minus is plus. So let me change it to plus. Now I have 1 by 10. When this one crosses, it becomes minus 1 by 6 equals 1 by V. So LCM here is 30. So that 10 in 30 is 3. 3 times 1 is 3 minus 6 in 30 is 5. 5 times 1 is 5 equals 1 by V. So 3 minus 5 is minus 2 by 30 equals 1 by V, which would mean, remember this is 1 by V is minus 2 by 30, which means that V is minus 30 by 2, which is minus what? 15. Remember, option. This minus describes the nature of the image to us. So it means that my answer is going to be 15 cm. Negative means what? Virtual. 15 cm virtual. So virtual is the nature. 15 cm is the position of the image. Then they say we should find magnification. So to get magnification, I would recall that magnification M is V over U, not minus V over U. It is V over U for length. So I have M as V. My V is minus 15. My U is minus 6. So if I solve this, it will give me what now? This is 7, 2 here, 3, 2 here is 7.5.
2.5.
2.5. So that's our magnification. So it means that the image is bigger than the object. That's what it means. So even without solving, you would see, if you look at what they gave us, you would notice that they gave us object distance as 6. They now gave us focal length as 10. If you had to draw this thing, you would see that this is how your lens is. This is our focal length. This is our focal point. So it means that from here to here is 10 actually. And your object distance is 6. It means that your object is between F and this. This is where your object would be. And when your object is between, definitely you expect magnification. You expect magnification. When your object is between F and your lens, your image will be formed on the same side, which is erect. And then it is what? Highly magnified. That's why you have a magnification of 2.5. Highly magnified. So if you see these things in options, you don't even need to solve. Once you know the properties, you can tick your answer. So quickly copy this. I'm giving you another one. I'm giving you 1 minute to copy. Can I move on? What are they saying? Can I move?
Nothing yet.
Okay.
Yes.
Yes. Okay. So this side can be captured, right?
Yes.
So we have another question which you are solving. An object is placed 25 cm from a thin diverging lens of focal length 20 cm, full stop. Determine the nature, position and magnification of image. So quickly, I want you to attempt this, then we can move on. We have solved one under convex. This is under concave. Remember, a diverging lens is a concave lens. So quickly solve this. I'm waiting for the answer, then I'll move on with other parameters on this. I'm waiting for the answer. Just giving you space to see the question well. I'm waiting for the answer. Any answer yet?
No.
How many persons are still present?
19.
19. You are trying. I believe some of you have shared, and I'm still waiting for others to share more. I want us to get 50 persons, and it's possible with you. Tell them to come and see what is happening. Share it to your group. Type, come and see what is happening here. Share it, please. I want 50 persons.
Yeah.
An answer now?
Yes.
Okay. Tell me, Charles.
Yes.
Got what?
V equals 11.11 cm.
Thank you.
Diminished.
Okay.
And magnification equals 0.444.
Okay, 0.44. Any other answer?
Not yet.
I'll give one more second and I'll solve. So the others will not see them. I think I should solve now. Now let's do it together. The question says, I hope you can capture it. Yeah? The question says, an object is placed 25 cm from a thin diverging lens. So we're dealing with a concave lens. And the object distance U is 25 cm. Remember, object distance for the two lenses are always negative. Now, of focal length 20, so the focal length F is 20 cm. Is it negative or positive? Of course, it should be what? Negative for our concave lens. Determine the nature. Nature means tell us whether it is real or whether it is inverted. Then position. Position of the image simply means V. And then magnification. So these are what they want us to find. I'm going to use my lens formula, which is 1 by F equals 1 by V minus 1 by U. So I have 1 by F is minus 20, 1 by V minus 1 by my U is negative 25. Now you expect that this negative times this negative becomes what? Positive. So I can quickly change it and just write positive here. So I want to find this. So what I'll quickly do is that I'll have minus 1 over 20. When this one comes, it becomes minus 1 over 25 equals 1 over V. Now my LCM, I'm going to take 100. 20 in 100 is what? 5. 5 times this is minus 5. Then minus 25 in 100. 4 times this is this. So this is what I have. So that minus 5 minus 4. I think I should drop here now. Minus 5 minus 4. So I have minus 9 over 100 equals 1 over V. So that V becomes 100 over minus 9. Tell me what we have in decimal.
11.11.
11
minus 11.11.
minus 11.11 cm. Now remember I said in your options you won't see minus, so you would see 11.11 cm, comma. Since it is negative, it means it is virtual. You don't even need a suit here. It is virtual, and this person got it. Thank you. So the next is to get magnification. So M, definitely my magnification must be 0 point something. As long as I'm dealing with a concave lens, it must be 0 point something. So let's check. V over U, my V is minus 11.11 over my U, which is minus 25. If I solve this, tell me what I have.
0.444.
0.444 and so on. So this person actually got it. I believe you are very much ready for exam. So keep studying like this, and trust me, you would see you won't go below A, right? So thank you. Every one of you on this live session, you will not get below A by the reason of this extra effort you are putting in. By now, you should have written this exam, but since there is strike and you are still putting in extra effort, you won't go below it. Trust me, God will help you. Now, I believe you have seen this, so screenshot or copy. Let's move on with further concepts under lenses. Let's move on. If you want me to move, say move. If you want me to wait, say wait quickly. All right, I think I can move, right?
Yeah, move.
Now I have up to 20 persons there.
Yeah.
So those that have shared, I really appreciate. So once you are joining, just hit the like button and then subscribe. Hit the subscription button if you are yet to subscribe, and then still share it so that some of them will come. I need up to 50 persons, and I know you can do it. So I need 50 persons on this live session before we end it. I want us to be up to 50, a minimum of 50. Now, we want to look at power of a lens. Power, which is very simple, nothing much about this. Power is the reciprocal of focal length when the focal length is measured in what? Meters. Power is the reciprocal of focal length when it is measured in what? Meters. So power, let me write. This is the reciprocal. This is the reciprocal of focal length when F is in meters. So that is power. Quickly, the formula says that P is 1 over F in meters. This is the formula for power. And the unit of power is diopter. Diopter, which is denoted with capital letter D. So this is all you need to know for power. A quick question. So screenshot this so I can write the quick question and you tell me the answer. Quick question. Now, let me see those that can reason far. For a converging lens, comma, U is 5 cm, when V is real and 2 cm. Find power. Find power. So I'm giving you this, solve it. I'm giving you a few seconds. I just framed it up, so we'll see how to solve it. And I believe that the parameters should work. So I'm waiting for you. Don't forget to share the video. Even immediately after our live stream, you share it to your class group. Share it to Prime Concept. I want to see the first person that will share it to Prime Concept group. Share it to your classes, Prime Concept. Tell them to still watch and follow what we have done so far. Any answer? No answer?
Yeah.
Okay.
Chukwuemeka said
0.7
D.
0.7 D. Any other person?
Ikechukwu 69.9.
69.9. All right.
Charles 0.7.
0.7. Okay. Now I want to solve. Remember, we're dealing with a converging lens. They gave us parameters. It says for a converging lens, U is 5. So for converging lens, U is 5 cm. Remember, U should always be negative. And they told us that the image is real. A real image has V as positive 2 cm. Find the power. So for me to find power, I want to first of all find F before I can now find power. Now, quickly, I have that 1 by f is 1 by v minus 1 by u. So 1 by f is equal to 1 by v. So 1 by 2 minus 1 by u, and my u is minus 5. So minus minus becomes plus. So I have that 1 by f is 1 by 2. How they can see here? Plus 1 by 5. So this is 1 by f equals LCM here is 10. 2 in 10 is 5. So I have 5. 5 in this is 2. So I have 7 by 10. Right?
Yes.
So it means that my f, let me still go. My 1 over f is 7 by 10. And then my f becomes 10 by 7. So this is what?
1.43. 1.43.
1.43 cm. That is it, my f. But is that what I'm looking for?
No.
No. I want to find my power. But remember, power is 1 over focal length when focal length is in meters. So I want to change this to meters. My 1.43 divided by 100. Do this for me. It's going to be 0.0143 meters. So I have that my power is going to be 1 over f, which is 1 over 0.0143. And the answer will be what?
69.9.
69.9 diopter. So thank you. So who got it? Ikechukwu. All right. All right. So we want to move. I'm giving you time to copy this. Let me also refill my marker. So copy. All right, I've refilled my marker. Now let me rub this quickly. Let's move. So we want to look at combination of lenses. Combination of lenses. Combination of lenses. Now, it is possible there are people that may have eye defect. They go to the hospital, the doctor would recommend a convex lens. There are people that will have eye defect. They go to the hospital, the doctor would recommend a concave lens. There are people that have a combined eye defect, that maybe those people cannot see both far things and close, recommend a combined lens for them. So it means for those kind of people, they can make their lens to contain both convex and concave combined together. So when you have a combination of two different lenses, how do you get the new focal length of that combination? That is what this thing is talking about, combined lenses. So when you have combined lenses, the focal length of the combination is going to be 1 over f equals 1 over f1 plus 1 over f2. So this is focal length of combination. It's just like you solving equivalent resistance, right, in electricity. So you say 1 over this equals 1 over this plus. That is it. Equivalent focal length or combined focal length is 1 over the focal length of the first lens, 1 over that of the second lens. So this is simple. Let me give you a quick example here to help you understand this. Let me see. So I have this two thin lenses in contact have a combined focal length of 10 cm. Full stop. If one of the lenses a focal length of 15 cm, determine the nature and focal length of the other lens. So this is the question I will be solving straight away to save our time. Now I hope they can see this side.
Yeah.
Now the question says two thin lenses. So we have two lenses that are in contact and they have a combined focal length of 10. So it means that F, which is the combination, is 10 cm. They said if one of the lenses has a focal length, so say F1 has a focal length of 15, determine the nature and focal length of the other. So very quickly we are going to solve, assuming they told us. If they did not tell us the type of lens that the first one is, you just assume it to be positive and solve. They say if one of the lenses has a focal length of 15, they didn't tell us whether it is convex or concave, so use this as positive. Then you solve for the second one. Whatever sign it carries will determine which lens it is. Now I have 1 by F equals 1 by F1 plus 1 by F2. So 1 by F, remember F is 10, equals 1 by F1, which is 15, plus 1 by F2. Now, I have 1 by 10 minus 1 by 15 equals 1 by F2. So that the LCM, I can use 30. So this in this is 3 times 1, 3 minus this in this 2. So I have this 1 by F2. So 3 minus 2 is 1 by 30 equals 1 by F2. So which means that F2 is actually what? 30 cm. Now remember, since our F2 is positive, it means that the nature of the second one, remember, when you have a positive focal length, it means that that lens is convex. So it means that the nature of that lens is that it is a converging lens. It is a converging lens. That is the nature. And it has a focal length of 30 cm. It is a converging lens. So copy. I want to move to the next part while we are already tidying up, but I have to mention a few more things. How many persons are there now?
17.
17. All right. So copy or screenshot. If you want me to move on, say move. If you want me to wait, say wait quickly so that I'll know which one I'm doing. Any response?
Not yet.
Okay. Any response?
Move.
All right. Now, we are done with combination of lenses. There's also something known as lens maker's formula. Lens maker's formula. If you check my channel, you still see the derivation. Now, for those that produce lens, there's a formula they use to calculate the focal length, because when you go to the hospital to complain that you have eye defect, the doctor would need to examine the focal length of your eye lens, so that from that calculation, from that examination, they can prescribe a particular focal length for you, right? Yeah, so it means that different lenses have their focal length. Now, those manufacturers of lenses, how do they determine the focal length of these lenses? The formula they use in making that calculation is what we know as lens maker's formula. So the formula that those that makes the lens use. So that is what we have. And what is the lens maker's formula? It is 1 by f equals n minus 1 into 1 by r1 minus 1 by r2. So this is the lens maker's formula. And in this formula, f is focal length, n is refractive index, r1 is radius of curvature of first surface, r2 is radius of second surface. So take note of these things, and I will explain very quickly. This also has a sign convention, which is important for us to know. Once you understand, we take one problem. So quickly, all right, I believe I can rub this now.
So wait.
Okay. Can I move now? Any response? If you want me to move, say move. That is why you are with your phone. I should move, right? No response?
Yeah, I think.
Okay. Now, this is when we say radius of curvature of the first surface. This is where you will now begin to meet plano-convex lens. They will tell you this lens is a plano-convex. You'll see problems for some of them. But say we have this. This is our convex lens. This simply means, remember, this is a biconvex lens. This is the first surface. So this particular place, the radius, if I should complete this sphere like this, you would see that the radius, this is R1 for this first surface. You have another surface. If I should complete it like this, then this is R2 actually, the radius of the second surface. That is what R1 and R2 actually means, right? Now, what is the sign convention here? Number one, I'm doing with for convex lens. I'm giving sign convention for convex lens. Number one is that focal length f is positive. That is number one. For convex lens, f is always positive when you want to use this formula, as long as it is a convex lens. Number two is that R1 is negative, R2 is positive. So this is the convention. This is the convention, which is very important. Take note of it. Then I'll give for concave. We'll copy it. If I meet you people there, come on, stop making noise. All right. Now, for concave lens, number one, f is negative. F is negative. Number two, R1 is positive. Number three, R2 is negative. So take note of this. Take note of this. So this is a sign convention we need. So let's take a quick problem so that we can see how to use this. So see the signs. I hope you have gotten it. I hope you have gotten the convention. Now, we have this question. An epiconvex lens of focal length 20 cm is made of material of refractive index 1.6. What are the radii of curvature of the lens surface? So I'm going to solve this fast. So I'm going to solve this. Now let's do it quickly together. The question says an equiconvex. So when you say equi means equal. So it means that a convex lens in which the two surfaces are equal. That is what it means. If the two surfaces of a convex lens are equal, it means they should have the same radius. That is what this term equiconvex means. So first thing you want to note is that R1 would be the same as R2. That is why they say it is equiconvex. And we can call this R, the radius R. See, if I get you people there, you are disturbing me. So sorry for the interruption. Now we have equiconvex means R1 is equal to R2. So we're going to set it as R since both of them are equal. So an equiconvex lens of focal length 20. So the focal length F is 20. Remember, we're dealing with a convex, whether it is equi or not equi. As long as it is convex lens, it matters to us. So for convex lens, the focal length is what? Negative, right? Yes, the focal length is negative, like I just gave you now. So we have this, and they gave us refractive index N as 1.6. So quickly, they want us to find the radii of curvature. So R. Once you get R, you've gotten R1 and R2 because they are the same. So using my formula, check whether this is projected. Using my formula, so I have 1 by F equals n minus 1 into 1 by R1 minus 1 by R2. So my F, so I have 1 by minus 20. Okay, sorry, this is positive. This is positive because it's a convex lens, right? Sorry for that. So I have my refractive index, which is 1.6 minus 1 into 1 by R1. Now we need to take note of something, so let's do it this way. First, let's say so that you don't get confused. Now, R1 is equal to R. R2 is also equal to R because they are equal, but we need to apply our sign convention. And what is the sign convention? We said for R1 is what? Positive. And then R2 is what? Negative. I hope that is what we said.
No.
For convex lens,
R1
sorry, for convex lens, R1, it means I made mistake in that convention. Let's get it very quickly. These are convex lens. And this is my R1, which is actually here. So I said the reverse. This is R1. This is R1, which is this surface. Then this is R2. So what did I say about R1 and R2?
R1 for convex lens, R1 is negative, R2 is positive.
No, there's a mistake. So let me rewrite that, because this side, you know, from your Cartesian plane, this side is positive and this side is negative. So let's make that correction. I don't know. So for our convex, let me rewrite it. For our convex lens, F, first of all, F is positive. I think this is what we said, right? For convex lens, F is positive, right?
Yeah.
Yes, this is 1, which is correct. Number 2 is that R1 is positive. R1 is positive. You can see it is on the right-hand side, which is positive. Left is negative. So number 3, R2 is negative. So remember it from this diagram, because you're right when you are plotting graph like this is positive, this is negative. So R1 falls on the right, so R1 should be positive. So if you reverse this, you get the convention for concave lens. So I think I should move on from this. So make this correction. The disturbance from the environment was just disturbing me. So make this correction so I can move on. Corrected it, right?
Yes.
So if you reverse these conventions, it becomes that of concave lens. Now let's see what I want to point out. Now, since we are dealing with convex, it means R1 is equal to positive R, and then R2 should be negative. It means R2 is equal to negative R. So you have to apply the convention there. Now, so I have 1/20 equals 1.6 minus 1. Then my R1 is R minus 1 over my R2 is minus R. So you will notice that this minus times this minus will become plus. So I have 1/20 equals 1.6 minus 1 is 0.6 into, I would have 1 over R. Minus minus becomes plus over R. So this is what I have. So I have 1/20 equals 0.6 into 1 plus 1 is 2 over R. I'm trying to find R. I would cross multiply. R times 1 is R equals 20 times 0.6 times 2. So this is how I would find my R. 24 centimeters. So this is my radius. So R1 is equal. So this is it. So copy very quickly. I want to tie the knot here. So copy fast. All right, so I want to quickly look at optical instruments now, see how fast I can summarize those instruments. I won't be talking about the eyes. Just check my channel, you'll see the eyes. So I want to look at optical instruments. Optical instruments. So the optical instruments we are going to consider would include simple microscope. Number 2, compound microscope. And number 3, the telescope. The telescope. So these are the optical instruments we are going to consider. I'm going to summarize. I won't be drawing diagrams. All these things are already on my channel, but for the sake of revision, we are doing it together. So these are the instruments we are going to consider. The eyes should be part of it. Well, I won't be wasting time there because it's very straightforward. Now, what is a simple microscope? A simple microscope is a convex lens in which the object is placed between the focal point and the lens. That is a simple microscope. This is a convex lens in which the object is between the focal point and the lens. So this is it. This is a simple microscope. Remember, I earlier mentioned that when object is placed between focal point and lens, then under that condition, the convex lens can be used as a simple microscope. So that's the definition of a simple microscope. Remember, a simple microscope can also be called a magnifying glass, a magnifying lens, or you call it hand lens. What are the basic things you want to know? What you just need to know for a microscope. Remember, a microscope is an instrument you use to magnify or to increase the size of a small object that is close. So first of all, microscopes are used to observe things that are close. Take note of that. Secondly, microscope serves to increase the size of those things. That is the essence of microscope. So when you say simple, it means it is just made of one lens. That is the difference between a simple microscope and a compound microscope. A simple microscope is simple because it is made of just one lens. Take note of all the points I've mentioned. One, microscopes are used to view near objects. Two, microscopes are used to increase the size of objects. Three, a simple microscope is made of one lens, which is a convex lens, and it operates under the condition that the object should lie between the focal point and the lens. So take note of it. Now, what is the next thing you want to know? If a simple microscope can increase the size of an object, that means a simple microscope is a magnifier. And what is the extent to which it can magnify? It is given by the formula m equals 1 minus v over f. We derived this formula today. This is the formula. But we usually replace v with d. And we say v is equal to minus d because if d is the image distance, it has to be negative to tell us it is virtual. What does d stand for? D stands for the least distance of distinct vision. D is called least distance of distinct vision. That is what we call D. So that what we are just trying to say is that the image is formed at this particular location. For a normal eyes, the least distance of distinct vision is actually approximately 25 cm, right? So what we're saying is that when you place an object between f and the lens, the image is usually going to be formed around this point. So that's why we replace the image distance with d, and we include the negative because image is virtual. So my magnification would now become 1 plus d over f. So this is the formula for magnification for a simple microscope. And this is all we need to know for a simple microscope, at least at this level, right? So copy, I want to rub and move to compound microscope. You want me to move because I'm drawing it to an end quickly. I think I can move. So I want to look at number 2, compound microscope. Compound microscope. What is a compound microscope? A compound microscope is an optical instrument that is used to increase the size of objects that are close to the lens. It is an optical instrument that is used to view near objects and increase their size. That is a compound microscope. And very importantly, a compound microscope is made of two lenses. A compound microscope is made of two lenses, and one of them, which is close to the object, is called objective lens. So for compound microscope, you have two lenses. One lens is just like this, my marker. If I can see through this, my marker, you see that the first place I can see through is this black place here, right? So this one is close to my eyes. Then this part will be close to the object, right? So just visualize it like that. I have two openings. This is one opening, which will be closer to my eyes. This is another opening closer to the object, right? So this one closer to the object is what you call objective lens. Then the second lens is the one close to the eye, which we call eyepiece. Eyepiece lens. So that is a compound microscope. And very importantly, for a compound microscope, the objective and eyepiece lens are both convex lenses. They are both convex lenses. So they can ask you, right? So both of them are convex lenses. Another point you should know is that the eyepiece lens has a longer or larger focal length. The eyepiece lens has a larger focal length. These are exam questions I'm bringing out as nugget points for you. The eyepiece lens has a longer or a larger focal length than the objective. So you should take note of this. Now, another point, number 3 point I want you to know. Number 3 is that the eyepiece lens, the compound microscope is arranged in a way such that the eyepiece lens behaves as a simple microscope. The eyepiece lens serves as a simple microscope. So these are 3 important points you should know for your compound microscope. So do well to either screenshot or write out these points. I want to rub. Okay, I think I still have space here. Can they see this side?
Yes.
Now, what is the formula for magnification of a compound microscope? We call it linear magnification. Linear magnification, right? For a compound microscope, the linear magnification is magnification of eyepiece, or let's say magnification of objective times magnification of eyepiece. So it means that the magnification for a compound microscope is the product of 2 magnification, which is the magnification of the objective lens times the magnification of what? Eyepiece. So if a question comes tomorrow, they give you the magnification MO of objective, give you that of eyepiece, say find the magnification of the compound microscope. It's going to be their product. So I believe you understand what I've said. Now, recall also that the objective lens, remember the objective lens is a normal convex lens, right? It's just a normal convex lens. And what is the formula for magnification for a normal convex lens? A normal lens, it is just V over U. So this is the magnification of our objective lens. Now, magnification of our eyepiece lens. Remember, for a compound microscope, your eyepiece lens serves as a simple microscope. So it means that the magnification of your eyepiece is going to be 1 plus D over Fe. That is focal length of eyepiece. If I combine these 2 formulas together in one, I will now get that my total magnification is MO V over U, right? I'll put minus because the final magnification is, the final image of the compound microscope is virtual, so I'll put minus to show that. Now, into 1 plus D over Fe. So Fe means focal length of eyepiece. VO means image distance of objective lens. UO means object distance of objective lens. So this is the final formula. The final formula. Then there are some approximations that are also made when you're using a compound microscope. One of the approximation is that V, the image distance, is approximately the same as the length of that microscope. Then 2 is that U, the object distance, is approximately the same as the focal length of the objective. So that if you replace these things, you can say that M is minus L over FO into 1 plus D over FE. This or this would serve. So under exam condition, they may decide not to give you VO or give you UO. They may decide to give you L. They say the length of the compound microscope is 20. The focal length of the objective lens is 30. They'll now say find magnification. You now start asking. So take note of these approximations so that if they give you, you can still use this formula. So the last thing we want to look at is our telescope. I'll summarize. I won't solve any problem for the sake of time. I'll summarize our telescope and then move on. How many persons are here now?
15.
15. Some persons have given up while others are waiting till the end.
So what is D?
D is what we said for simple microscope. Distance, D is least distance of distinct vision. Least distance of distinct vision. Right? It's just a position where image is usually formed, right? Which we said for a normal eye. If you're viewing something from a normal eye, the distance is approximately 25 cm. So it's just a specific distance which has been observed for people with normal eyes whenever they are using glasses, lenses. So that distance is D. So call it least distance of distinct vision. Now I want to talk about the telescope, which is the last thing I'm talking about now. So for our telescope, a telescope is an optical instrument for viewing distant objects. Take note. Telescope is an optical instrument for viewing distant objects. Remember, compound microscope is for viewing near objects. Telescope is for viewing distant objects, objects that are far, such as the heavenly bodies. When you say heavenly bodies, you're talking of planets. So it means you use your telescope to view things such as stars, planets, other planets, Mercury. That is what your telescope does, right? Yes. So telescope is for viewing distant objects. Viewing distant objects. Right? Now, your telescope is also made of two lenses. Number one is objective lens. Objective lens. Number two is your eyepiece lens, similar to that of our microscope, compound microscope. So it has two lenses, objective and eyepiece. One point I want you to note is that the two lenses, they are both convex lenses also. They are both convex lenses, just like in your compound microscope. Remember, this is actually what we're studying is astronomical telescope. We also have Galilean telescope, which is not part of our studies for our course outline, what we are following. So we're looking at astronomical telescope, which is actually this. Galilean has different lenses. Now, so they are both convex lenses. That is one point you should note. Now, the objective lens has a larger focal length. You should take note of this. The objective lens has a larger focal length, unlike in compound microscope. Now, number 3 points I want you to note also. The objective lens has a larger focal length. What was the third point I mentioned for compound microscope? Compound microscope.
The eyepiece lens has a longer.
Second point.
The eyepiece lens serves as a simple microscope.
Okay. So it means this one we have just two. Anyway, let me add a third one. Now, for our telescope, it is arranged so that the focal length of eyepiece and objective coincides. So take note of that. The the telescope is arranged so that the eyepiece lens, the focal length of the eyepiece and that of the objective lens, so that both of them coincide. This is very important. This is the arrangement, so that the two focal lengths meet each other. And under the condition, what is the formula for magnification for telescope? For telescope, we talk about angular magnification. Angular magnification, right? And it is given as this m theta, angular magnification. Angular magnification is the ratio of angles subtended by image, angles subtended by image to angle subtended by object. So this is angular magnification. Sometimes they will give you those angles, you find this. And sometimes they won't give you angles, they will give you focal length. If you solve, angular magnification is also FO over FE. So this is angular magnification. Either you use this or you use this, depending on what you are given in the question. Then finally, the length of telescope. The length of telescope, that is to say how long a telescope is. For example, if this my marker is a telescope, the length of the tube, you can either say the length of the tube or the length of the telescope. For you to find the length of the telescope, it is L equals FO plus FE. So this is the formula for finding the length of a telescope. And with these few points of mine, I've come to a conclusion on optics, at least for the sake of our revision. In my next class, I'll be looking at waves, and my next class might fall in next week, either Sunday or Monday or Tuesday, but I will communicate the day to us. So we have done a lot for today's class. We covered a whole lot in today's class. I believe we have spent up to 2 hours already. So, and this is actually the end of today's class. So the next class will be communicated to us. So thanks to those that participated in this class. Thanks to those that shared the video. Please, one of the things I want you to also do for me is the moment we finish this video, it is also important that you drop a comment. It will help YouTube recommend the video to other people. Don't just end the video and leave. You come back and check. You drop a comment. The class was okay. You tell us how the class was. Drop a comment so that others can actually see the video. Then share the video. Share it to Prime Concept group. Share it back to our group. Share it to your class group. Tell others that what is happening in this YouTube channel is very important and nobody should miss. If you have friends in other universities, some of you are in UNN, if you have friends in UNIZIC, OAU, UNILAG, please share it to them because they need it. It's the same concept everybody is studying. This is physics, same theory everywhere. So share to your friends and God will bless you. So do like the video if you have not liked. Let's give a shout out to those that are around.
Thank you. Top fans.
Top fans, thank you.
You have love it.
Love it. Congratulations and thank you for waiting.
MS.
MS, thank you. Congratulations.
Kwebuka.
Chukwebuka, is it John Paul?
Yeah.
Okay, thank you, John Paul. Consistent.
Ikechukwu.
Ikechukwu.
Charles.
Ikechukwu and Charles, or this different persons?
Yes, different persons.
Ikechukwu, thank you. Charles, thank you.
Chikechisom.
Chikechisom.
Chidinma.
Precious.
Chris Amarachi.
Emmanuel. Washman.
Eze Melody.
Ikemdelim.
Nweke Blessing.
Prosper.
Ubo Juliet.
Chukwubikem.
Newtlin.
Newtlin, thank you so much. So one of the things I want you to do, once we end the video, I want you to drop your departments on the comment section. Tell me your department. I want to know your department. Thanks for watching. I'll see you in my next session.
Give them 2 minutes to copy because we are lucky.
Okay. So I believe you can see it. You can quickly screenshot this. So I think you needed to copy this. So you can quickly screenshot this. So please, once we end the live session, drop your department on the comment section. I would like to know. Tell me, this is John Paul. Tell me, this is Ernest. Tell me, this is Chinedu. Drop it and tell me your department, please. I would like to know your department. Remember, we're going to still have more live revision classes, even for electromagnetism. For those that are still yet to write their exam, we're still going to fix more live sessions for that. So thanks for this. I believe everybody has gotten this, right?
Yeah, ask them.
So if you are done copying this, tell me so that we can end it. If you have just say we are done. Tell me you are done so that we can end the session for today. Just quickly type we are done so that we can end the session for today. Quickly type, tell us you are done. They are done, right?
Yeah, one person.
Eh?
One person.
Okay, I need another person to say we are done so we can confirm. If you are done, quickly say you are done so that we can end.
Okay.
They are done.
2 persons.
Okay, so we can end it now.
Thank you, guys.
All right. Thank you. Thank you. Thank you. God bless you.